This is the first lecture for Chapter 5, and it's a short lecture, but it has an important concept, and once you get the concept, the rest of the course actually makes sense. The corresponding material in the text is in section 5.1. The first idea here is that we're going to move from the discrete variables in Chapter 4 to continuous variables in this and subsequent chapters. So in a discrete random variable, the values were found by counting. And the type of experiments we were talking about was rolling dice, tossing a coin, or a situation such as a game where you have win or lose outcome. Since that's discrete, it's either plus or minus, 0, 1. Okay. Now for continuous variables, the values are determined by measuring or weighing. Examples would be blood pressure, temperature, heights and weights of individuals, measurements of some object that is made in the shop, and those are continuous variables. For the discrete variables, the probability distribution was shown like this. There were bars. Okay? And the probability actually is the height of the bar. So here the values, the discrete counted values, are on the horizontal axis, and the probability itself is on the y-axis. Now this is going to change to something different for continuous variables. For the continuous variable, instead of bars, you'll have a line. So here's an example of a continuous probability distribution. These would be the values for the data, and they can vary continuously from 100, for example, to 120 to 140. They aren't restricted to 100, 120, 140. It can have any value between. So the result is a line, a solid line. But the big difference here, that sort of makes sense, but the big difference is what is on the vertical axis. It is no longer the probability. Instead, it's what's called the probability density. So this is a probability density. You cannot use it directly to find the probability. You have to find instead the area under the curve. I'll show that in the next slide. So here's the big concept for Chapter 5. For these continuous variables, the y-axis gives the probability density. To find the actual probability, say between 100 and 101, you have to find this area that's underneath the curve between 100 and 101. So the shaded in area, the size of this area, is the actual probability. Okay, so if I wanted the probability between 98 and 99, I would have to find this area underneath the curve. So how do you find this area? Actually, it's not an easy task. So it's done by tables in the back of the book, or better yet, it's done by software. And we're pretty much going to use software, but before we do that, we have to understand a little bit about these areas so we have sort of a framework in our mind. But this is the whole concept right here. So if you get this concept, then you're good for hypothesis testing, confidence intervals, pretty much the rest of the class.